That's right. So welcome again to the Building Decarbonization and Energy Efficiency Strategies for Municipal Buildings training. Certainly a mouthful. As always, we're going to get started with the lesson overview. So today we're really diving in deeper into how do I decarbonize my municipality's buildings. Our learning objectives are identifying where to start on the municipal decarbonization journey, identifying the barriers and considerations of electrification and how to overcome them, and understanding the various funding sources available to municipalities and schools to study facilities. So we'll jump into our introductory polls. We're just interested in learning more about where you're coming from in terms of these different learning objectives. So to what extent do you agree or disagree with these statements? I'll give you guys a minute to take that. Like 20 more seconds if you haven't already responded. All right. So let's in this poll. We have excitingly a lot of agrees. So hoping throughout this training and through the MESM training that we can shift that from agree to strongly agree. But it seems like a lot of folks agree on knowing where to start on the municipal decarbonization journey. Lots of folks agree on understanding the barriers and considerations of electrification and how to overcome them. I see a couple disagree or neutrals. And kind of a mixed bag in terms of understanding the various funding sources. So hopefully throughout this training, we can get folks more comfortable with those. All right, so I'm gonna ask our speakers to introduce themselves and then invite them to take over the slide share.
Sure. I'm Kevin Silvera with National Grid. Many of you probably have already spoken with me. I am I've been doing electrification for the past like 5 years now. With that, I'll pass it over to Greg.
Thanks, Kevin and Julie. Yep, I'm Greg Stein, Eversource. I've probably worked with some of you. If not, I'm sure I will soon. Provide customer support, looking at decarbonization strategies for a variety of municipal buildings. Want to go to the next slide, Kevin. Were you going to take this one or?
Oh, sure, I can take this one.
Yeah.
So today we're going to just be discussing mass safe technical assessments, assistance, pre-electrification barriers and strategies, get an overview of the existing heating systems, uh, let you know about some heat pump solutions, and then go into some case studies. So part one is pre-electrification, and with this, I'll hand it to Greg.
Thanks, Kevin. So you may have heard some buzz around some of the new decarbonization studies that are being offered, and we'll talk more about those this morning. That would include the portfolio prioritization plan, the comprehensive building assessment, as well as technical assistance studies or focus studies. If you could go to the next slide, please, Kevin. This graphic here shows kind of like a potential study flow, from kind of looking at taking a very early stage look at decarbonization of your portfolio all the way to project implementation. So really the intent of the PPP is kind of an early stage benchmarking effort where we gather data about the buildings, and the typical outcome would be a CBA or a more detailed study of like the high priority buildings. And once some design decisions have been made, we can do a focus study, which would help us determine, concrete energy savings values and incentive support, um, towards implementing the project. Um, Worth noting too that it don't necessarily have to go in that order. So doing a PPP is not a prerequisite of doing a CBA, nor is a CBA a prerequisite to do a focus study if a project's been designed already. We can kind of pick up anywhere, meet you where you're at in terms of the project development stage. So maybe we'll go to the next stage slide, please, Kevin. So the PPP, here's a nice example of one on the screen here, where it's probably about 20 or so buildings we had looked at. It's a good way if you're new to managing a bunch of buildings to get a handle on which are the better or poorer performing within your portfolio in terms of their energy consumption. Um, which ones might have, we'll call it like the term we use are triggering events for decarbonization. So for example, if we're looking at, um, we'll be looking at each building's mechanical equipment. And oftentimes, if a piece of equipment's getting near the end of its life, that's a good time to start proactively planning to decarbonize that equipment. We try to encourage folks or come up with a plan to do planned replacement as opposed to emergency equipment replacement. So the PPP is a really good starting point to kind of get a handle on things. It's typically fully funded by the Mass Save program. Maybe go to the next slide. And I forgot to mention that the PPP would identify buildings that are good opportunities for doing a comprehensive building assessment. So the CBA will take a more detailed look at individual buildings, checking for efficiency opportunities, our typical energy efficiency measures like envelope measures, lighting, ventilation system improvements, as well as I guess like an ASHRAE level 2 evaluation of um, decarbonization or electrification opportunities. We like to look at all different technology types and what it would take to implement, whether we do like kind of a hybrid strategy or full displacement, um, to better understand what barriers may exist or what like technical feasibility constraints may exist for a given technology type to really give a good sense on. We want to empower you guys to be able to make a decision on what like the best fit is for that particular site. Um, so we can go to the next one.
All
And I
right,
think
this
Kevin,
is
you're taking up here.
yeah, I'll take from here. So when we are talking about electrifying buildings, there's really a three systems problem. We need to look at the generation, the distribution, and the end use of a building and make sure that all three are working together to actually decarbonize a building. Um, if we put a bunch of solar or wind on the grid and the grid's not sized to handle it, it doesn't do any help. And even if the generation's there and the distribution's there, if your building's not ready to accept that clean energy and use it, it doesn't decarbonize anything. So we do need to look at the three systems working together in order to decarbonize our building. And with this, we kind of go into the distribution and the end use. So before we start thinking about just, all right, we have a building, we're just going to slap in electric resistance and call it a day. This graphic kind of shows that is a very bad strategy when you kind of think of cost. The cost of electricity is much more expensive than natural gas is today, and our grid would be way overloaded if we did just do a switch to electric resistance. So we need to think of electrification as not just switching to electric heat, but a reduce energy and switch to heat pump systems. So when people talk about the grid can't handle full electrification, it's not true, but it's much more complicated than people want to talk about. So in our existing grid infrastructure, there are lines that have plenty of extra capacities, and there are lines that don't have any extra capacity. So in a city, you might have sections that are fine. You can add electric load to the systems, and then there's other parts of the city that you just we're tapped out for our lines. So we can help, and we do evaluate these conditions when looking at a PPP and the CBAs. And if you have a building that you're like, hey, we kind of just want an idea, you can always work with us to get an idea of what that building's grid is looking like. So with that, even if the grid is fine and can handle it, it doesn't mean your existing building's infrastructure can handle it. I just kind of want to bring this down to a house level. If your house has a 100 amp panel and you want to fully electrify it, it might not be possible. But if your house has a 200 amp panel already using air conditioning, it's much more likely that putting in heat pumps to your home wouldn't be an issue. Same thing happens with your buildings. Just your existing infrastructure might be able or might not be able to allow for electrification to happen. And in our studies, we kind of give high level understandings of if your existing infrastructure could handle it. So with that, reducing any any energy load in your building helps reduce that required upgrade or that required usage. So a great example here is my own home. We moved in 2021, and the first year we opened up a wall and realized there was no existing wall insulation and very little attic insulation. The previous owners were using about 7 tanks of oil a year. After we insulated it, it went down to 3 tanks a year. So weatherization and insulation is really important when looking at buildings. However, some buildings you can't really do anything that's not going to cost millions of dollars, whereas other buildings there are opportunities. So ventilation is a very important part of the formula when we're talking about electrification. Most buildings today, bringing outside air, you heat it up with either hydronics or a furnace or an RTU, and then you take that nice heated air and exhaust it out through the exhaust systems. Ventilation, energy recovery ventilation is an important step where we actually cross those air streams through either a energy recovery wheel or a flat plate heat exchanger to preheat that incoming air. For typical buildings, we're looking at about 40% of your energy use could be just heating ventilation. With an ERV, you can easily reduce that 40%. You can get 20% savings in your building with just an ERV. There is a lot of difficulty of installing this, but there are events that might happen in your building that make it easier. So for example, in a school, if you're replacing the roof, this might be a great opportunity to implement energy recovery in conjunction with that project because you're already removing that roof and creating new penetrations or removing old penetrations is a lot easier when you're already doing a project. So looking at your distribution systems, it's very important to, if replacing them, to go to low temperatures. So say you have a building where you have steam distribution, the distribution's over 100 years old. There's really not much we can do to utilize that system when converting to a heat pump system. However, when we're looking at hydraulic systems, there could be opportunity to switch those over to low temperature systems. For example, you're in a school and your unit ventilators are failing. To switch out those unit ventilators to low temperature unit ventilators is possible and makes it much easier in the future to switch over to like an air to water heat pump. So other pre-electrification projects are just reducing that electrical load as much as possible, be it VFDs, transformers, removing compressed air systems, or updating lighting. All projects that reduce that load frees up capacity for those heat pumps. So if you're able to reduce your electrical consumption to the point where a service grade might not be needed, it makes the project much quicker to implement and not need costly electrical upgrades. Also, when thinking about electrifying your building, you need to keep in mind backup and resilience for your building. If your current building is on a generator that's sized to do the boilers, that system will not be sized to do a heat pump system. Like, you are really increasing your electrical consumption, so you need to take that into account. But we can install electrical battery backups or thermal battery backup as a way to offset the existing generators. There are technologies that are advancing every day that could help assist that. So with that, I kind of want to take some time to look at full versus partial electrification. When we're looking at these buildings, the majority of your energy consumption happens above 30 degrees. So partially electrifying your building can go a long way to reducing your greenhouse gas emissions and doing it at a fraction of the price. As you get lower and lower temperatures, the efficiency of those heat pumps to move heat reduces, and therefore your electrical capacity needs to be increased in order to achieve that electrification. So when thinking out a building and you're going after full electrification and you get all the design done and it happens to be that there's not the existing building electrical infrastructure or grid infrastructure to handle that 0 degree switchover temperature or the design day temperature, it could be where you look at a 15-degree switchover temperature, leave that existing boiler in place, and you could achieve a 90% reduction in your greenhouse in your fossil fuel consumption with that slight tweak. And then there are opportunities in the future to get that last 10%, be it adding insulation, adding possible battery storage systems that could help you achieve that. So my takeaway from this slide is, don't let the perfect be the enemy of the good. Try to go for full electrification, but if that's too expensive or just not feasible in the timeline, partial electrification could get us 90% there faster and cheaper than going after that 100% right away. All right, so we'll start with the learning check. I'm not sure how to get that started. There it is. All right, it looked like a couple more coming in. I think that most people have voted. So the answer is true. In a CBA, we will look and identify different barriers to the electrification, be it the existing distribution system needs to be replaced, or that the existing electrical infrastructure to the building is undersized, or that the grid capacity is not there there could be constraints on the grid. All right, and with that, I'm just going to take some time to go over the existing energy systems to kind of give a better understanding before Greg goes over the possible solutions. So to start off, steam systems. So steam is the biggest challenge when we're talking about electrification due to there's really no existing infrastructure that could be tapped into. So we're really starting from point one when designing the system. Steam distribution has been around since the early late 1800s. So in this building, you'll see probably very large radiators in your building, or very, very hot heat when it comes on. That brings us to hot water boilers. So there's two types of uh, hot water boilers in a typical building. There's non-condensing units and condensing units. The non-condensing boilers have the way to identify them is a steel exhaust pipe coming out of the building, or a metal one, versus condensing ones typically have PVC exhaust vents for the combustion air. Sometimes in condensing boilers, you'll have fresh air intake and exhaust system to the boilers. When looking at a condensing boiler in your building, there might be the opportunity that the building has low temperature out distribution systems with them, which could make it easier for a partial or full electrification opportunity. Condensing boilers are much more efficient than the non-condensing options. Just a good understanding of what those systems are. So these hot water boilers can provide heat to air handlers, rooftop units, baseboards, a lot of different distribution systems that could be connected to these systems. And there's different strategies we could look at when we are replacing them or partially displacing them. For our programs, we can always leave those systems in place for backup. Just one thought to have. So with that goes, we can start talking about furnaces. So furnaces heat the air to a building. So in a typical building, there is a supply and return ductwork to these furnaces. There will be an exhaust flue from the furnace to the outside, and there will be either a gas connection or a propane connection to that furnace, or electric resistance could be the case as well. And with that comes to rooftop units. So rooftop units are packaged systems that are on the roof. These can be just air conditioning, they can be just cooling, just heating, and they can do heating and cooling as well. These systems can be electric resistance, natural gas, or propane systems. They can provide heat to one portion of your building or your entire building. They come in different sizes, ranges from like 3-ton systems up to like 50-ton systems. Next, we have the most complex system kind of out there, the variable air volume system. This system's really for newer buildings and larger buildings, might not be in any of your municipalities, might be in some of them. Really, only buildings around 2000, built in the 2000s, would have this system. So basically, you have an air handler that is providing either cooled air or neutral air to VAV boxes. And at that case, either in the summer, they're just kind of varying how much cold air goes to the space, or in the winter, it's bringing in neutral outside air, and the VAV box is doing all the heating. Those VAV boxes can be hydronically fed or electric resistance, and they can kind of you can have simultaneously heating and cooling in a building in this configuration. And with that, I will kick it over to Greg to kind of discuss the electrification options for a building.
Sure, thanks, Kevin. So this might be the category of heat pump equipment most folks are familiar with and have seen at their homes. Air source or split type air source heat pumps. They're pretty standard. You have your outdoor condenser, and there's a variety of so that would be your outdoor unit, and then your indoor units could be like a wall mounted head, such as in this photo here. There's also ceiling mounted cassettes, floor mount, uh, ducted distribution. It can be configured a number of different ways. Um, the new equipment's very efficient, even down to like these cold climate air source heat pumps, even down to very cold temperatures. They have a high efficiency, or for heat pump, it's evaluated with a coefficient of performance. Um, so you might hear like COP, the higher the COP value, the better. Um, so that's a good key term to understand. Um, can be applied for a variety. Like you could do very small buildings with this type of technology, or larger buildings, like entire schools could be retrofit with air source heat pumps. For smaller projects up to 150 tons, there's prescriptive rebates available, both for retrofit and new construction programs. For larger projects over 150 total equipment tons, we could look at potentially as a custom project. We'll go to the next slide. Kevin had mentioned RTUs. There's a number of RTUs on the market now that incorporate heat pump technology, similar to air source heat pumps, the split type units we were just looking at. There's prescriptive rebates of $2,000 a ton for retrofit projects, or 800 a ton for new construction. um, Larger projects or projects that serve variable air volume systems, we'd want to look at a custom basis. But for your typical, um, unit like for like replacement of a single zone RTU, usually that's a project we could handle with a prescriptive application. One other technology we're seeing some success with, or seeing implementation with, are these are hybrid uh, heat pump RTUs, which use typically natural gas for heating at uh, lower ambient temp conditions. Um, and that can ensure performance and comfort when it's really cold out. It can also be a strategy to electrify within what the electric capacity of the building can support too. So that's one benefit of taking a hybrid approach, is you can select for equipment and a sequence of operations that wouldn't necessarily result in a net increase on the electrical demand on the building, if it'd be very burdensome to make updates, or there's limited capacity available in the street. So hybrid RTUs could be a good fit for that type of situation. Where just like the VAV situation, it's important to note, like, actually we go back to that slide, the VAV
Oh,
slide there. Um,
can we go to the VAV slide?
Yeah, the VAV one. So you can see here, actually, Kevin had touched on it, but most of the heating is actually being done by the boiler in this type of scenario. Even if the RTU or air handling units are placed with a heat pump section, so there'd be less gas savings. So, like for example, if we're doing a CBA here, we'd look at how do we adjust both the air handler, the RTU, as well as the boiler serving those VAV boxes. So that's what we'd look at in a CBA. We can go to the VRF. VRF is similar in some ways to the air source heat pumps we looked at before. However, they have higher efficiencies and have the ability to do what's called heat recovery, or um, simultaneous heating and cooling. So this is pretty common in like large office buildings that have like a center core section, which might have a year-round cooling load. You're able to actually move heat from the perimeter rooms um, to the center. You're able to move heat around within the building to where it's needed, rather than um, using the outside ambient temperatures to as a heat source for that. So that can really increase the coefficient of performance when there's year-round simultaneous heating and cooling loads. Um, can be configured in a very wide number of system configurations, but with cassettes, heads that are mounted on a wall, air handling units. There's a ton of technology available on the market now for VRF. Um, and it can be handled for smaller projects. There's prescriptive rebates available, and for larger projects or hybrid projects, we could look at on a custom basis. We'll go to the next one. This LEV kits, so the LEV stands for linear expansion valve. So basically, it's a component of a air handling unit or heat pump system rather. So these kits allow us to retrofit newer rooftop units or air handling units with a heat pump coil, which is served by a heat pump outside condensing unit. Um, Scenarios where I could see this being a good fit would be, for example, if you had to replace an air handler or RTU, kind of like an emergency situation, and weren't able to select for like a hybrid heat pump RTU just because you needed something in the immediate term off the shelf, we could go back later and retrofit that unit with a heat pump coil to help decarbonize that space that's served by that equipment. These are can be looked at either prescriptively or custom. I guess it would depend. And I think if you're considering this technology, you'd want to contact early in the process your Mass Save representative. Air to water heat pumps or heat pump chillers are a great solution for particular if you have a chiller, um, an air cooled chiller in particular. These can be used to replace that so they can generate heated or chilled water. It's a good potential partial electrification strategy. One thing to note with these, they can also work well as a boiler replacement or in tandem with an existing boiler to do some pretty significant work in the heating season. It's worth noting that Kevin had touched on low temperature conversion earlier. The equipment that's available on the market now generally has a lower temperature output capacity than that of a boiler. Um, and the higher the temperature output, the kind of the COP or the efficiency can suffer a bit. So there's kind of a balance point where it makes sense to run your air to water heat pump and perhaps use an existing boiler for backup at colder ambient temps. There are no prescriptive rebates available for this type of equipment, given how variable, I guess, the application of it would be. We could look at it on a custom basis. Um, there's a number of advantages to it. There's reduced refrigerant within the living spaces. That's something that's a concern, safety concern. That's eliminated through use of an air to water heat pump. And it can sometimes be more of a drop-in type solution to your existing system as opposed to like air source heat pumps or VRF, where you'd be installing an entirely new system in most cases. Next slide, please. And then the last, I guess, overarching technology type would be ground source heat pumps. These have the highest prescriptive incentives available, but they're also one of the more costly to install, just given the relative complexity of the system and the need to install some type of ground heat exchanger, whether it's wells or buried loop. You can see several options in this graphic here. One nice thing about geothermal is the efficiencies or COP of the system generally tends to be higher because of the relative stability of ground temps as opposed to air temps. But the con would be higher first cost of installation and generally a more complex retrofit. So you'd be looking at generally a full system replacement. Um, Similar to like if you were replacing a steam system, you're kind of starting from square one um, with geothermal in most cases, I would say. I think that's all I wanted to cover on that. Yeah, we got the learning check here. I see answers coming in. A variety of answers coming in. All right, I think we could stop there. We got about 3/4 of folks responded. So this one, in my mind, the best answer would be C, air to water heat pump or heat pump chiller. Um, that could be considered like a drop-in replacement and get some immediate decarbonization, even if it can't fully supply the heating load for the space. Um, so, thinking about your buildings, a good early stage opportunity for decarbonization would be with buildings that have aging chillers that may need to be replaced soon. We try to identify those as a high priority item, both in the PPP and CBA studies. And with that, I think we'll pass it off to, so we have Dele and
Yep.
Susan that wanted to talk about some case studies.
Dele, did you want to start? And do you want to just share your own, or do you want me to continue driving?
You're on mute,
All right.
David.
Okay, yeah, can you hear me?
Yeah, now we can.
Okay, yeah, good. So basically, the presentation I just want to give very, very briefly is just to talk about how we've actually made use of the CBA, in the city of Lean specifically. So this first chart we've got here, this little cyclical one, is just basically to show that the CBA is really it's just an instrument that is part of a wide varieties of instruments you might be using in your in your municipality, basically. So I'm not really going to go into this because describing this chart basically has to do with what is happening in your own municipality and the models of, procurement and things of that sort. But the two important things to really note from this particular chart is the fact that the CBA, obviously the one we get from, from Massey, for example, which is in between the actual level 1 and 2, it's going to serve as a really very good template, for you to do your costing and for project scoping. So I'm just going to basically talk into how these two aspects, I'm just going to highlight the costing and the project scoping aspect in the two case studies that I'll be presenting. Next slide, please. Next slide, please. Okay, very good. So in the first one here, really, it's for one of our high schools, Lean Vocational Technical Institute, and the CB actually served a lot of purposes, but I'm just going to highlight two purposes, and I was just try to basically center that on the roles of a municipal energy manager. So, firstly, we're able to make use of this particular CBA, and we're able to stack the ECMs to specific grants. Now, this is really very important because yes, the CBA is going to give you that template, but it's really very important for you to basically understand which one of those ECMs, as prescribed by the CBA, would match a particular grant. So that actually takes you working with your project managers, your project facilitators, or your inspection services, or whatever department in the municipality actually does that, basically. So my role, especially was for a recently applied TESA grant, was we really needed to effectively translate some of those ECMs into specific, like rubrics as those grant provided. So the next one has to do with, how you want to basically utilize ECMs towards electrification. As you know, we've had these really very interesting talks also. From my experience, basically, I actually realized that yes, the ECM could basically state certain electrification measures. For example, I give a really very simple example here where we've got ERVs. Now, ERVs in this particular building, you could say, okay, you've got classrooms, but then if it's for some of our elementary school or some other schools, when you say classrooms, it's general, and you could just size the ERVs, with a standard, standard cost models and things of that sort. But in the case of tech, being a technical institute, not all those classrooms are actually generic classrooms. Some of them are laboratories. So I had to basically work with our project managers effectively to look into ASHRAE 62.1, that code. It has to do with indoor ventilation. So what it actually tells you is the fact that although ERVs is necessary, you will not be able to apply ERVs across all the units that are considered classrooms in that particular school. So that's basically one way for you to contextualize, the CBA which you've got. And this is really one of the importance of the walkthrough, which you actually do in certain cases. So I just want to bring out these two, main examples from that perspective. And then next slide, please. Next slide, please. Okay. Next, okay, thank you. Good. So for the second one, which is a Fallon, an elementary school, this is an older building. The first one, was a building in 1971, but this particular building is in the 19th century, 1895. But we're actually still using this building basically because recently it actually had a very new use case basically, and so we're actually moving forward with the electrification for this building. But as you would imagine, effectively, the CBA actually found that we do require, a lot of weatherization and envelope improvement, basically. But that wasn't actually suggested by the ECM because there are a lot of abatement issues and also the cost issues. So in this situation, whilst the CBA could actually give you that recommendation, it basically give you that I identify that particular problem. It's not necessary that it has to be done because in this situation, we actually have certain things that are prohibitive to that. But some of the basic weatherization, like the doors and windows for this building, has been done to a certain minimum in such a way that we can actually move ahead with some of with some of the recommended measures in terms of electrification for the second building. So just to basically talk through a summary of everything I've actually talked about. The last slide is just what I want to just talk through very quickly for the last slide, basically. Next slide, please. So just trying to contextualize this, from the perspective, from my experience, I've actually found that the MEI is a really very important tool. So in fact, the portfolio prioritization, that's the prioritization plan, the PPP that has actually been proposed. I really do think that it's advisable to really use that particular PPP together with the recommendations from from the MEI, because what the MEI does basically is the fact that on the dashboard it immediately gives you some of your buildings to target, and these is actually be compared with with a CBEC standard effectively, and that's really like a starting point for you to go if you want to look into buildings you might want to incorporate into some kind of portfolio plan and things of that sort basically. And then obviously it is very important for you to have a very good record of the previous ECMs, because if I take you back to the grant matching we talked about, when you're trying to match grants, it's not just in cash, basically. You have to do it in kind in certain situations. And that means that some previous ECM measures must have been done in that particular unit before you can actually make very strong arguments for that particular building, to be a candidate for a grant, basically. And then the greenhouse gas emissions. And I think with this, it's a little bit challenging. And I would even propose that we kind of incorporate training on actually understanding greenhouse gas emissions with respect to our energy savings, because some of this data could actually be multifaceted, really, in the sense that different standards could give you different kind of like metrics for calculating greenhouse gas emissions, basically. But I really do think it's also very important because some grants could actually give you a certain greenhouse gas displacement that your proposed project should actually have. And sometimes the CBA might not necessarily give you that information. So it basically means that the MEM might actually have to work with the engineers doing the CBA and things of that sort, basically. And then finally, I'll just talk about the fact that the project implementation should be phased. And I think we all understand that, basically, in the sense that we have to prioritize the ECMs. Not all the ECMs have to be done at once. Thank you very much.
Hi there, I'm Susan McPhee, and I work with Spark Energy Conservation. So we're a team of people. We have 6 cities and towns in the greater Boston area. But today I'm going to talk about the Medfield Library, where we did a rooftop heat pump conversion, so a partial electrification. The background here is I started working with Medfield in about 2021. So first steps, walk every single building in town with the facilities team, understand what their pain points are, what their limitations are, but especially, as I think Greg mentioned, where the limitations are on what equipment is reaching its end of useful life. So the library, when we walked it in 2021, was costing a lot to maintain. they were constantly having to run over and repair things. So it's an old masonry building. It's about turn of the century, and there are gas boilers in the basement that are still there. They remained, but there were 6 rooftop units, gas-fired rooftop units that were failing and cost over $10,000, between $10,000 and $20,000 every year to maintain. So given that, when we were looking for projects to scope, we identified those rooftop units as potential for partial electrification. The team at Rise Engineering scoped the project. Next slide, please. We applied for a Green Communities grant in the spring of 2023. Here are the economics. The total project cost for replacing 6 rooftop units was about $235,000. So we were able to do a large amount of that with the Green Communities grant and then utility incentives, and the town did wind up contributing as well. So the application went in the spring of 2023. We were replacing 6 units, 3 7.5-ton units, 2 5-ton units, and 1 4-ton unit. And these were Lennox units. The project was projected to save about 6,100 therms and increase the electricity usage at the building by about 74,000 kilowatt hours annually. So one of the learnings here is deferred maintenance in a lot of our communities. Medfield, I should say, is a town. It's a small community, about 13,000 residents, open town meeting. So oftentimes it's hard for municipalities to replace big things, to get big projects done. Things are often kicked down the road. We can make it last another year. We can make it last another year. So then you wind up with a huge backlog of deferred maintenance and equipment replacements that are teed up that need to be done. So one note is to really talk to your facilities people, see what's on the list of things that could imminently fail. And if there are some of these things like replacing a chiller or replacing the RTUs where you can partially electrify, then that's a really great, you're saving the town capital, you're taking something off their potential fail list. So looking for that, where those two things cross, the facilities needs plus what's the equipment that is available for partial electrification. So we applied in the spring of 2023, and we got the award in November of 2023. So contracting began. The calendar is kind of interesting here because contracting can take a long time. Contracting began and was completed by the spring of 2024. So it really took almost 6 months just to get through all the contracting with the state and purchase orders, contracting with Rise. So in spring of 2024, we're ready to launch. Next slide, please. We tee this all up, and it then takes about 6 months for the equipment to be manufactured. The equipment ships in November of 2024, and is received in December. So this install, you can see the crane there. This is staging everything. So this all happened in January of 2025. So it really takes a long time to get through the process, getting the contracts and everything in place, and then getting the equipment manufactured and shipped. So that's another learning is you can't really guarantee when these things are going to take place. With the best of intentions, it can take 6 or 9 months for equipment to be produced and then shipped. So next slide, please. The equipment, you can see this is a very crowded roof. You think, oh my gosh, there's a rooftop unit. And so the slides that we saw from Eversource and National Grid, it looks like, oh great, we're just going to pop this lovely little unit. You can see this roof was packed. So I think it's miraculous that they got all 6 of these rooftop units gracefully, removed and then installed. The curbs have to be accurate. You can see at the base of each unit, there's a curb that it has to be fit into. So the installation, the crane arrived on January 6th. The installation took from the 7th through several days. It was largely completed by the 21st. However, then one control board in one of the units was faulty. So that's another learning. You never know everything, best of intentions. We did need one control board, but largely it was completed and functioning. One control board was replaced. There was a training on site. That's another thing. You want to make sure that there's ample training for your people, your operators, the people who are living that building, to understand how the controls work, how the equipment interacts with the existing systems, so forth. Next slide, please. These are some of the units. So you can see our lovely brand spanking new units with ice on them and snow because the installation was in January. Next slide, please. So very lovely. And last but not least, next slide. Here are the results. So we've had not quite a full calendar year of the heat pumps on the roof. There is natural gas backup, but as you can see, there's barely any orange line on that bar graph on the right. So we've used hardly any gas as far as we can tell. Excuse me, as far as we can tell. And then, yeah, so it's a happy story. Our electricity use is definitely up, but it's not up so significantly. So my takeaway is that probably the cooling element of those RTUs was fairly inefficient. And now we've replaced it with much more efficient equipment. And then we've largely walked away from those boilers in the basement so that we're heating and cooling with the RTUs. The facilities director is very pleased. Operation is super smooth. The building occupants are happy. Costs are up. This did not save the town money on operating the building, but it's not up terribly dramatically. It's an affordable up, but we've largely electrified and eliminated a lot of carbon. So in my view, I think everybody's pretty happy with this project.
Thanks so much, Susan. I know we are starting to get questions for you in the chat, but I wanted to stop screen sharing and open up the room for discussion. So let me stop spotlighting you. So if anyone has any questions, either for Dele, for Kevin, for Greg,